All right. Hello. In this lesson, we are going to be looking at how to graph what are called cubic functions using our knowledge of transformations. So, cubic functions are functions where we have an expression involving x that is raised to the third power. So, the key points that we transfer, similar to how we were given a graph and we determined key points from that graph and we transformed those in the previous lesson. Here, we will use the key points of what we call the parent function, and we will always transform these same points for these cubic function problems. So that requires that we have a knowledge of when we raise integers to the third power, what it's equal to. Understanding that -2 to the third power, which means -2 times -2 times -2 will equal a -8. And a -1 to the third power would be -1. 0 to the third is 0. 1 cubed means 1 times 1 times 1, which is still 1. And then 2, positive 2 to the third power, would give us a positive 8. Those are actually going to become the values of x and y in our key points that we'll see here in a moment. So this is showing us a graph of the cubic function parent, which is f of x or y equals x cubed, and that is what we see here. All right. And the key points that we are always going to transform are shown in this particular graph, these 5 points. Notice the curvature of this particular function, how in this case from the left side it heads up and sort of arcs towards this middle point, and then it changes to sort of a U-shape, half U-shape or bowl shape as it continues on the other side. This point right here in the middle, our 0, 0 point in this graph, is a point of inflection, which I mentioned it a little bit in an earlier lesson. It's where a curve changes its direction from what we call concave up to concave down. So it kind of sweeps through that middle point and changes how it curves, whether it's an arch type situation or a bowl type situation. This is talking about how we perform our transformations, which we are doing the same thing that we were doing in the previous graphing lesson. You want to make sure that after you identify all your transformations, that what you do first are any reflections, stretches, or compressions. And you want to make sure that what you always do last are your translations. Any translations, left or right, up or down, always do those last to make sure that your graph is done correctly. All right, here's going to be our first example. We have a couple of parts here. Always make sure that you read the directions in full and sometimes reread them later on in the problem so you don't forget to do parts. So notice here, the first thing we're going to do is graph our function using transformations, and here's the function that we're graphing. But after we complete that graph, we have a second part. We have to determine what the 0 is of this function, or if we can't say exactly what the 0 is, like if it's between two integer values, then we'll say what interval the 0 is in. Like, is the 0 between 2 and 3? Is the 0 between -3 and -2? If we can't say exactly what it is, we'll say what it's between. And that's what it means by consecutive integers, integers that are in order to one another. All right, so we want to start by identifying our transformations. So here we see our first parameter of 2 being outside in front of our parentheses would be a. Since it's positive, that tells us we do not have an x-axis reflection. The absolute value of a would be the absolute value of 2, which is of course still 2 and greater than 1. So this is our factor, and since our factor is greater than 1, we know we have a stretch, and we've learned with our a that it's a vertical stretch. So we have a vertical stretch, and our factor is 2, which remember means that we're going to take those vertical distances and we are going to stretch them by a factor of 2. So it's like multiplying by 2. And then what we want to make sure here is that we understand that by being a vertical stretch, that this is a stretch in either the up or the down direction. So it stretches points above the x-axis further above, and it stretches points below the x-axis further below. All right, then our next parameter, the -4, remember we have to take the opposite of that to get our correct h value. So our h value would be +4, and that gives us a translation to the right 4 units. And then our final parameter here of the minus or -1 is our k. Don't take the opposite of that one, remember. And being negative, we go in the negative direction from the origin, which for k, which is about vertical translations, would be down. So this tells us we're going to go down 1 point also, or 1 unit also. So what are we doing these transformations to? What points? The points that we're going to have to use are the key points from our cubic function, because we have that exponent of 3. So the points that we have to transform come from taking the x values that are the integers from -2 to +2. So -2, -1, 0, 1, 2. And their y values, which are the cubes of those. So -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. These are the 5 points we always transform for these problems where we're graphing a cubic function. All right, so when we are graphing functions this way, where we kind of don't have the points on the graph, we have points that we're using, I've written them over here, it can be helpful to understand where they're going to go, especially with a stretch, which makes them stretch away or farther from, in this case, the x-axis. So the y values here are actually what are going to be stretched by our factor of 2. So we're going to take each of these y's times 2. And notice that 8 times 2 turns it into a 16, and -8 times 2 turns it into a -16. So they are stretching to +16 and -16 before they translate right and down. The reason I point that out right now is because you'll notice we don't have any axes on this little graph situation. So we have to draw our own axes in such a way that we can graph as many of these points as possible. So here, what we're going to do is count up the number of squares that we have and then figure out where it's best to put the axes. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21 squares. The distance from -16 to +16 is 32 units. I don't have 32 squares. So what that tells me is if I'm going to get all of these onto my graph, I'm going to have to change the y-axis scale to counting by 2s. So when I draw my axes, I'm going to want to make sure that I put in numbers to remind myself that each line vertically is going to actually be 2 units. And we've seen graphs like that in the previous lesson. Because I have this right 4 units, that is going to be like taking this 2 and adding 4 to it, which is going to move it to an x value of 6. So I want to make sure that I have at least 6 squares to the right of the y-axis. So I'm going to draw my y-axis to over here. So I have enough room on my grid for that right 4 translation. And then I'm going to draw my x-axis pretty much in the middle because I'm going to use a scale of 2 units. So I need at least 8 squares. Actually, in this case, because I have a down one, I need at least 9 or 10 squares below my x-axis and a little fewer up above because I'm moving down one also. So 1, 2, 3, 4, 6, 8, 10. And so I'm going to put my x-axis right around there. Now my x-axis, I'm just going to count by 1. So this would be 1, 2, 3, 4, 5, 6. And then for my y-axis, remember, I've determined I want to change my scale to a 2-unit scale. So this is 2, 4, 6, 8, 10, and so on. And then down here, my negatives, counting by 2s. Put my negatives over there too for reference. All right, so now I'm going to start transforming my points. And I want to, of course, do my stretch first, and I want to do my translations last. So it doesn't really matter which point you start with, but the recommendation I kind of have when you're first doing this is start with one of, these aren't really end points, but they're, the furthest points that we have. So start with -2, -8, and work to the right, or start with 2, 8 and work to the left. If you could also start, some people like to start with 0, 0 and then work outwards, and that's okay too. So it's sort of your choice what you want to start with. I'm going to start with the -2, -8 though, all right, and then work my way through the other points. So -2, I've really got to pay attention to my scale numbers here because -2, -8 is going to be right here. So it's starting here. Now it's going to stretch by that factor of 2. So -8 times 2 takes it down here to -16. Then I'm going to move right 4 according to my scale. And my scale on my x is 1s. So I'm going to count 4 squares or units to the right. 1, 2, 3, 1, 2, 3, 4. And then I have to go up 1 unit. Here's where it's tricky, because my scale for y is 2 units. Going up 1 puts me in the middle right there. All right, and then realize, oops, I went the wrong direction. I went up 1 instead of down 1. So from here, I actually need to go down 1, which would be in the middle of that spot right there. It's always a good thing to look stuff over and make sure that you went the right directions, because it happens to all of us at some point that we go in the wrong direction on accident. All right, so now I'm going to do the -1, -1 point. And this one's a little tricky too, because here's -1 for x, but -1 for y is right there in that middle. So it's going to stretch first, and -1 times 2 is -2. So it stretches to right there. Then it translates 4 units to the right. 1, 2, 3, 4, and 1 unit down. So it gets in the middle right there. Now, here's where learning this curve is important. Remember what the curve looks like? So when we're looking at our curve, this portion is what we're looking at right here right now, okay? So they're connected by a kind of a gently sloping line. So if you wanted to connect them right now, you could, but now this isn't an end point, so it actually keeps going, and you put a little arrow on the end, and then it's gently connecting to that point. So now I'm going to transform 0, 0. Remember that the stretch does not affect 0, 0, because 0 times 2 is still 0, but this point does translate. All points translate. So it translates right 4, 1, 2, 3, 4 units, and down 1 unit puts it right in the middle right there. And remember, this is that little arch piece. So now it's arching towards that middle point. Then we're looking at 1, 1. So here's where 1, 1, whoops, that's not where 1, 1 starts. 1, 1 starts there because of that y-axis scale being 2 units. So now it's going to stretch by a factor of 2. 1 times 2 is 2, so it stretches to this line where the 2 is, and then it translates 4 to the right, units, 1, 2, 3, 4, and down 1 unit to the middle of the square right there. Now, do you remember what this side of the curve starts to look like? This is where you have a little bowl or U shape, so it changes its direction through from the other side of that point right there. All right, we got 1 more to go. 2, 8. So 2, 8 with my scale here starts right there. Stretches first. 2 times 8 is 16. So it stretches up here to the 16. Then it translates 4 units to the right. 1, 2, 3, 4. And then 1 unit down, so it ends up in the middle of that right there. And then this is a gently connecting. Try not to let it wiggle like mine was doing. And then keep going. That's not an end point. That's just the last of our key points. So this time you keep going and then put an arrow on the end. And this is now our g of x graph. All right, and then after all of that hard work, we want to make sure we don't forget about our part B here, which says either determine the 0 or the interval of consecutive integers in which the 0 occurs. So the 0, remember, is where our function crosses the x-axis. And it's not at a particular number here. So we're going to say which interval of integers it's between. So if I'm looking here at my scale, remember for x is 1. So this is 1, 2, this is 3, that's 4, and then this is 5. So I can tell my 0 is somewhere between 4 and 5. So for part B, I would make a conclusion that the 0 is in the interval. Don't say the 0 is here, because an interval isn't a 0. A 0 is a single number, so we say the 0 is in the interval, and then we have our interval 4 to 5, like so. All right, so this one is just asking us to graph, actually. So here's the function we're going to graph. We don't have a part B here. So here we're going to graph using transformations. So again, same procedure. We know that we're going to use the key points we're talking about today because of that exponent of 3. That makes this what we call a cubic function and tells us that our points that we will transform in just a moment are those points where the integers from -2 to 2 are cubed. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. But before we can do anything, of course, we need to know what our transformations are. So now our first parameter here is our 2. And so we've learned by its position inside parentheses times the x minus h part that that is our 1 over b parameter. So we know 1 over b is 2, which being an integer has a denominator of 1. And that's important because this is the one we have to do the reciprocal of. So b would be 1 over 2. Now being positive, that tells us we do not have a reflection across the y-axis. And then we look at the absolute value of b, and the absolute value of 1/2 is still 1/2 because absolute value is always a positive value. Compared to 1, 1/2 is less than 1, and that's 1/2 is our factor. So we know that any time our factor is less than 1, we have a compression. We've learned with our b parameter that the type of compression is horizontal. So we have a horizontal compression. Our factor for that compression, what we're going to multiply by, is 1/2. And remember, being horizontal, the distances it compresses are the distances on the left and right of the y-axis. So horizontal compression takes points on the left side of the y-axis and moves them closer to the y-axis. It takes points on the right side of the y-axis and moves them closer to the y-axis. In this case, by multiplying by 2, or remember, you could multiply by 1/2 rather, or you could divide by 2. That works also for the math here. Now, with this structure, you need to realize that your h here would be 0 because there's nothing added or subtracted after the x. We don't have to worry about that. And the +5, which is after the parentheses, would be our k. And so we have a k of 5. And k is about translations up or down. So being positive, we're going to go in the positive direction from the origin, which would be up those 5 units. All right, for this one, when we look to draw our axes, it's good to understand, again, how things are going to change before you actually start doing the changes on the graph. So with a horizontal compression, it takes those horizontal points and moves them closer to the y-axis. So it means that it is compressing or changing the x coordinates by dividing them by 2 or multiplying them by 1/2. So we're actually looking at -2 being divided by 2 and becoming -1. We're looking at -1 being divided by 2 and becoming -1/2. 0 divided by 2 is still 0. 1 divided by 2 becomes 1/2, and 2 divided by 2 becomes 1. Realizing that right now helps me realize, well, that's going to push everything really close to the origin and the y-axis, and so it might be a good idea then to use a scale of a 1/2 unit for our x-axis. We don't have to worry about changing the y-axis scale because the only thing that's going to happen to these y values from -8 to 8 is that they're going to go up 5. And the 8 plus 5 is going to become a 13. So the only thing I need to realize here is that I need to be able to get up to 13 for my y's. All right, so I'm going to draw my axes. So I don't have any horizontal translations, and so I'm just going to put my y-axis in the middle. My x-axis, I'm going to drop down a little bit because remember I need to get up to a y value of 13. So I want to make sure I've got at least 13 squares above my x-axis. So I'm going to count here. 2, 4, 6, just lost it. 2, 4, 6, 8, 10, 12. There's 13. I'll drop it down even one more. So there's my x. Here's my y. My y's, I'm just going to use a scale of 1 unit. So each line is going to be 1 unit. So this would be 1, 2, 3, 4, 5, 6, and so on. For my x-axis, because of this horizontal compression that's going to give me these really small numbers, I'm going to use a 1/2 unit. So that means that this first line is going to be a 1/2 unit. So this will be 1. The next line would be 1 1/2, and my next line will be my 2. And on the negative side, the first line will be -1 1/2, and then the next line is -1, then -1 1/2, and -2. And this will help make graphing easier because it will spread out my points a little bit better to make drawing the curve through them easier. So it's a strategy just to make the graphing easier. All right, so now we're going to start transforming our points. Again, we need to do the horizontal compression first, and we need to move up 5 last. So, taking my -2, -8, what's going to happen with it is going to compress by a half. So -2, being all of these 4 squares, compresses to half of that, which is -1, and then it moves up 5. So it's like taking -8 and adding 5 to it, which would move it up here to -3. So it ends up here at -1, -3. -1, -1, which starts right here, compresses by a factor of half horizontally, so it moves right here to that half mark, and then it moves up 5 units. 1, 2, 3, 4, 5, and it ends up here at -1/2, 4. 0, 0. Compression doesn't change that because it's at the origin, anything times 0, 0, but it does still move up 5. 1, 2, 3, 4, 5, and ends up right here. So this is that left side of my curve, which these are gently connected, and it arches up to that middle point. Arrow on the end there. Then I've got my 1, 1. So 1, 1 actually starts right here. So I do that horizontal compression. So this 2 squares compresses to half of that, which is 1 square, which is at 1/2, which makes sense because 1 divided by 2 is a half, or 1 times a half is a half. Then it moves up 5. 1, 2, 3, 4, 5, and ends up right there. Remember, this is where it changes to a bowl shape on the other side. Then we've got 2, 8, which starts off right here. So it compresses horizontally half of this distance. So it moves from +2 to +1, or from 4 squares to 2 squares, and then it moves up 5 units. 1, 2, 3, 4, 5, and it hits that 13, which is where I would expect it to hit, since 8 plus 5 is 13. And that then gets connected to the previous point. That's really messy. Let me try again. Go on through that point, remember, and put an arrow on the end. And that gives us the graph here of g of x. All right, for this example, again, we're just looking at doing a graph. Here's our function. And this one can be a little tricky when you're doing these on your own, so you want to be on the lookout for this structure where you have inside your parentheses your x, but then no other parentheses, because we have a little bit of a trouble here if we don't recognize that we have to change this structure, because the structure that we need when we're inside parentheses is 1/b times x minus h. That's what we need. And we don't have these extra parentheses inside the parentheses we see. So we've actually got to factor out that number, which is a -1. So we're going to have to rewrite this with our -1 out here. It's like treating -1 as a GCF. And so -1 divided by -1 is 1, so that gives us 1x. +3 divided by -1 is -3, so that becomes -3. And then we still have our cubed on the outside. That's important because we need to make sure we get the correct h value, which is actually +3, not -3, because it's the opposite of the -3 that gives us h. And by the position of the -1, that's our 1/b. So here, being -1, which is -1/1, then b becomes 1 over negative 1, which is still negative 1. Being negative, it does give us that y-axis reflection. The absolute value of b is the absolute value of negative 1, which is 1. And so what this tells us is there's no stretch, no compression. Because our factor of 1 is not bigger than 1, it's not smaller than 1, it is 1, which at anything times 1 is itself. So that's the idea. If you multiply times 1, it doesn't change, which means there's no stretch, no compression. Then we have our h, which remember we were just talking about has to be the opposite of this negative 3. So our h value is positive 3, which is going to take us to the right, those 3 units. So we have to do our reflection first, and we have to go right last. All right, so cubic function with that exponent of 3, that tells us those points we have to transform come from our parent function. So they are always negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, 2, 8. All right, so our y-axis reflection is it's like taking our x's times negative 1. So it moves negative 2 to positive 2, negative 1 to positive 1, 0 stays, 1 becomes negative 1, 2 becomes negative 2. And then they will move right 3. So the biggest deal is that positive 2 is going to move further to the right 3 to a 5. So I want to make sure when I draw my axes that I have at least 5 squares over here. So I've got 2, 4, 6, 7, so I got plenty. I don't have to worry about my y's changing at all this time because my reflection is a y-axis reflection, and I don't have a horizontal I don't have any vertical stretches or compressions. I don't have any translations up or down. So those are actually going to stay exactly as they are right now. So I'm just going to put my x-axis in the middle. So now my scales. There's really no reason to change any scale because my numbers are all going to stay relatively the same. They're just going to change signs and get 3 added to them in some cases. So I'm going to use scales of 1 unit for both. So this for y, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do the negatives, the same scale. And then my x's, I'm going to use a scale of 1 also. So this is 1, 2, 3, 4, 5, 6. And my negatives, negative 1, negative 2. So now I'm going to start transforming my points. So negative 2, negative 8 starts right here. Have to do that y-axis reflection first. So it's going to flip from the left side to the right side. So it's moving to positive 2. And then it's going to translate 3 units to the right. So from here we count 3 more units to the right. 1, 2, 3. And it ends up right there. Then I take my negative 1, which starts right here. Then it reflects across my y-axis, so it flips to the right side. And then it translates 3 units to the right. 1, 2, 3, and ends up here at 4, negative 1. Then I have 0, 0. The reflection doesn't affect it because anything times 0 is 0, but it does still move right 3. 1, 2, 3. Now that's my middle point. Here's another tricky thing. When you have these reflections, now your low point is over here on the right, which means that this side is actually your arch side. and doing the arch down to that last point. All right, so now we're going to transform our 1, 1. So 1, 1 starts here. The y-axis reflection takes it from the right side of the y-axis, flips it over to the left side. And then the translation takes it 3 units back to the right. 1, 2, 3, puts it right there at 2, 1. And then finally 2, 8. So 2, 8 starts here. The reflection takes it from the right side to the left side of the y-axis. And then the translation moves it to the right 3 units. 1, 2, 3. And its final spot is right here. So this is the top half of my curve. So this is my U-shaped or bowl-shaped half. And so this comes down and makes a little U or bowl shape on that side. And that completes our g of x graph. All right, so that will finish up this lesson, and I hope you have a lovely, lovely day.